Good morning. It's still before 12, so okay. My name is Karol Kwiatek. I'm from ArcelorMittal, Poland. Thank you, Professor, for the invitation. The topic of the presentation that I have here today is Steelworks for Zero, TLS, UAV, 3D, 360, GIS, and VR. There are a lot of abbreviations that maybe they are difficult right now, but I hope they will be a little bit easier for you to understand at the end of the presentation. So I started my work in ArcelorMittal 5 years ago, and all the topics that are mentioned here, they were not available at that time in the company, but I managed to start and develop quite well, and there are lots of projects doing such projects right now in the company. TLS is telestial laser scanning. UAV is something that we call them drones. Yeah, 3D modeling, 360 visualizations, GIS, geographical information system, and virtual reality. This is the path. This was a roadmap that I designed at the beginning, and I'm still following this road. Just a few words about the company. The company has 6 different branches in the south of Poland. There is one more in Warsaw, but it's a separate company. Also ArcelorMittal Poland, and 2 main branches are in Krakow and in Dąbrowa Górnicza. They are big ones. This company produces steel, so it's one of the biggest steel industry company. This is one of the biggest company in the steel industry in the world. So the quality of how we produce is very important, and I would like to mention a number of issues that are going to this direction. So this is the roadmap that I created at the beginning of my work. That I learned that there are a lot of Word document and Excel files that people are sharing and switching emails and so on. So I propose to go from Excel and Word files to virtual reality. So we need 3D, like 3D models, 3D modeling to do this, a lot of databases, document management systems, GIS, which will link all the documents by the application of a map, and then we have like a 360 movies, 360 visualization that will help people to understand and to introduce some kind of topics. We are all going to the direction of digital twin. We would like to have all the company have a digital digital twin in a computer, and we would like to merge them with different processes. And GIS, we want to have them on the map. We would like to see how every component of the building is, how it was created, where is the deadline of the where it should be checked, and so on. All the processes that we have in the company can be also presented on the example of the digital twin. And what is crucial, is this virtual reality step. Yeah? Once we have this digital twin, once we have this digital factory, then we can go forward to digital twin. Let's imagine that we can discuss the projects between our different branches, between our different continents, using the virtual reality headsets. This is what I created, and I started to gather all the 3D information from the company, because before I start my work in ArcelorMittal, every company that they did a project, they took the data with them, and the data was separated. Right now, I collect all the data that are related to all the issues that are here, the topics that are here in one place, and people can see what happened in the past 2 years ago. They can check everything in 2D and 3D, and not only in Excel and files. The first topic, telestial laser scanning. This is a process of high accurate measurements. Yeah? This process creates millions of points per second. So imagine that, let's say, there are lots of diagrams like this showing how the whole looks like. Yeah? But we are not the people that work there. They were not sure whether it's up to date or not. Yeah? So if something changed or not, because they didn't update such drawings. Yeah? And terrestrial laser scanning is a process that allows them to see what is the really up-to-date situation of the building or the hall. And this process produces a point cloud. Point cloud can have billions of points, and it's really difficult sometimes to handle because we need fast computers and so on. Here you can see the map of a big hole. It's almost 1 kilometer long, where there are lots of different difficult equipment, difficult to handle equipment, different roads, cars can get inside and so on, and you have to see, you can try to navigate this. You can, by the application of the points here, you can click a point and you can ask, you can see this as a 360-degree interactive viewer by the application. I'm sure you know Google Street View, yeah? So you can also have something like this inside the factory. Once you have this, you can visualize this. There are also some problems related to terrestrial laser scanning here, because this is based on laser measurements. Yeah? So once the scanner is not going to see something that is behind the table, it will be not measured. Yeah? So you have to put this equipment on the other side in order to measure something that is not visible from this place. So I hope to show you this movie that will present just a quick overview of what we have inside. Yeah? You are not allowed to get there without special equipment, uniform, and so on. So you just go through. This is a point cloud. Yes, it's not a movie. This is something that was produced by the application of terrestrial laser scanner. This equipment costs about, I don't know, 100, 200,000 zloty. Yeah? So it's not so cheap equipment, but there are more expensive ones. Okay. And then, this is an example of a street view that we have there. It's not only a street view that you can also see images, but you can measure. So let's say you just click this button, measure, and you can check what is the distance between two points, wherever you want. Yeah, it's in 3D. Yeah? So you can check whether the equipment that you are going to order will fit, let's say, to this path or to this road. There are lots of possibilities that you can do in this system. Okay, the next step is UAV. So we started to use drones 4 years ago. I created some kind of a workflow how we can use them. So this drone can collect thousands of images in a few minutes. So I propose to use the photogrammetry, which is the process of converting images to 3D models. And you can do this by, as you can see here, there are separate images that were created by drone that flow over some kind of a terrain, or you can just rotate this drone. You can fly over an object, and then after some time, by the application of the photogrammetric software, you can create a 3D model. Why do you need this 3D model from drones? First, you can create a map, very accurate map. It could be less than even 1 centimeter up to a few millimeters. You can see all the details. You can measure even all the details that you have there. You can count them by zooming in to this part. The orthophoto map is one product that you can create. The second one is like an extra output. It's a point cloud. Yeah, this is something that you can also create by the application of terrestrial laser scanning. But this was created only from images. Without laser scanning was not used. This is the example of zoom in to some part. As you can see, not everything was covered. There are some holes due to the lack of information of images. Okay, now we have a point cloud, and what we can do next? I propose to do a 3D model. The 3D modeling is a process of converting point clouds. So we have billions of point clouds. And we would like to present them in a nice way and send these files to companies that they are doing some kind of engineering works for us. Yeah? So they prefer to have 3D models. So the 3D modeling is a process of converting point clouds, lots of billion point clouds, to simple objects like a pipe, and things like this. The objects that can be mathematically well presented and written. So you don't need information about every point cloud in a 3D space, but you just only need information about the radius of the pipe, the beginning and the end, and that's all. Yeah? You need only 3 small information about this. So you need, this is the process of simplifying the point cloud, okay? This is the process of 3D modeling of a blast furnace that happened in Dąbrowa Górnicza. This is the second biggest branch of ArcelorMittal. We have one in Krakow, and in Dąbrowa Górnicza there are 2 big ones. The rest is there are smaller branches. And this is a process of converting this point cloud to a 3D model. This is what company they need from us. And as you can see, it's a lot of data. Yeah, it's almost 280 gigabytes. It's a simple point cloud. Okay? The data, it's transferring this data is a problem for us right now, because we have terabytes of different projects, and we are still gathering this. This is an example of of the application of different colors for different pipes, different objects that you have over there. And what is important, according to the quality, is that you have to define the level of details. And before you order this kind of a 3D modeling externally, this can be done also by the external company, you have to order the specific level of details. Yeah? So it's low level of details. You don't have a barrier here. You only have information about the valve here. But here, in this case, this barrier close to the stairs is very well 3D model, but this one costs quite a lot. Yeah? This one can be done quite quickly. Sometimes there are even automatic solutions for this, but this one is quite expensive. Yeah? So you have to calculate what level of details do you want to do. And this is an example of, let's say, this is a 3D model of blast furnace in Dąbrowa Górnicza. It is divided into a lot of different layers, so you can find the specific parts of this. This 3D model was created on the basis of laser scanning that I mentioned at the beginning. And why do we need this? Let's say here we are trying to create some kind of a new installation on this blast furnace at the top. And it's difficult to predict what will happen, whether an equipment. Let's say we would like to have a ladder here, and we can check this in 3D model whether it fits or not. Yes, this is very simple, basic example. Yeah? But there are lots of different applications of this. Something that is like that I used in different topics. I mean, health and safety, and also HR. It's a 360-degree visualizations, which allows us to quickly show the site, how it looks. This is the example of the. Do we have internet? No. Okay. Where is my mouse? Okay, we don't have internet. Oh, maybe it will be possible to do this. Okay, I'm going. Yeah. I'm not sure if it's going to load. Okay, so I will just go to the next slide. And this is an example of the 360-degree video that was recorded on the helmet of a guy that is driving some kind of a ladder inside this big hole. As you can see here, it was very difficult for me and for other people that are working in this space to persuade our managers and directors that it's not a very safe place for people. As you can see, there are people going. This is the front of the ladder, and this is the back, and this is the back. This is, as you can see, this you can. I would like to maybe show you this example. This is a 360 video that you can look all around. Yes, so. This is presented on a flat surface, but this is the beginning, and this is the back. No, this is the front, and this is the back. Yeah, as you can see, it's not very enough space for people on the left and the right to fit, and it's very risky. So this video showed helped us to change the system of transporting some kind of items that we have there. I also use this 360 visualization for health and safety. This is an example of the the video, 360 video that I created, and people realize that the item that is going to fall, it will move. Yeah, so they have to move as far as according to the height of the item. You see, this is the item, and it could fall, and they have to move a little bit, and they have to understand it. And we use 360-degree goggles and virtual reality to this. In order to create this kind of more advanced 360-degree films, I use this kind of new video editing software where you don't edit this on a flat surface, but you edit video in 3D. Yeah? So it's a little bit more advanced way of creating this. Okay. The next is GIS. This is something that binds all the different technologies, and it's important because once the installation is, something that is designed by external companies, once it's provided to the company, it should fit to the map, to the perfect place. Yeah, it cannot be moved 5 centimeters right or back or down. It has to be in the right coordinate system. And once everything is properly defined, it should work. And this is another aspect to the quality. The quality of measurements has a very important role to the next steps of digitalization. Let's say GIS can be also used for visualization of different kind of old maps that we have in the company. Let's say this is a map of the Rzeszowice branch in Opole region, where a lot of people use this old map on the paper, and I managed to put this on a map in a digital form. And right now it's easy for them to use this. This is an example of a map that we bought from the government office, but the problem is that the maps that we have from, or we can buy from government office that is related to the land surveying, the maps are not up to date. This is because the people that work in the company, they didn't send this data about updates to the government office. Yeah? So there are some lacks, very big missing parts of, let's say, underground system. Yeah? So here is example of water system, and this is a paper document that everything is described, well measured by the land surveyor in the past, but this information is missing in the digital form. Yeah? So lots of data has to be transformed. And I started some kind of a process like this with teletechnical network. As you can see here, very important fiber network cables. Yeah? They were marked, they were drawn on a paper by a specialist, yeah? And this specialist is just about to go to the retirement. Yeah? So this knowledge that he has in his mind is very, very important. So I managed to create some kind of a system for him, easy to use. He is using 3 buttons in GIS system. This system is open source, and he is drawing this hand by hand, every part by part, and he is very close to success to finish this before the retirement. But this project took 1.5 years, and it should took another few months. Before, they had maps in Excel. Excel is not the software for creating maps, and even in PowerPoint. Yeah, they use this because they had no knowledge about other programs. Yeah, and that's why we have problems right now. But we are trying to do this a little bit better. Inventory of cable cabinets, example. Yeah, some of them are well described, but some of them are really in a very not good condition, I can say, yeah? And sometimes papers are sticked here and no one knows what is inside, yeah? So everything has to be everything has to do, we are doing this inventory, yeah? It's a challenging task, yeah? Example of this one, yeah? They started to open every item like this. They check what is inside, there's water in most cases. Some of them are not in the good conditions. We are checking them on a map, whether they are in a good condition. This one is very nice, yeah, but there are some of them are just under the big piles of ground. Yeah, so sometimes it's not easy to find them. The last step is virtual reality. This is what I managed to design and create in ArcelorMittal. This one is in Dąbrowa Górnicza. So whenever you want to test something here, I'm happy to collaborate. We have HTC Vive Pro there, and you can use we are using this, or no, we are starting using this because we had this room. We have had this room for about 2 years, but we are starting using this for health and safety trainings. The first health and safety training should be by the end of June. So as you can see, this is the room that one person can see. It's virtual reality stuff, but the other people can observe and see how this person works. Yeah? In this virtual reality environment, we can put 3D models that I mentioned at the beginning. The 3D models came from TLS laser scanning, whatever you want. You can check this. You can create health and safety trainings. You can create trainings for HR department to introduce new workers to see whether they can work inside. And this is the example of a 3D model that we are also trying to use